Hello, let us. ठीक है, just I am going to start this lecture now. देखो, there are 23 pairs of chromosome in each somatic cell of the human being. How many chromosomes? 23 pairs of the chromosomes are present in somatic cells of the human beings. So the number of chromosomes is fixed for all species, and the individuals of in all the individuals of the same species have same number of chromosome, and the number of chromosome varies from species to species. As for example, the pea plant has 7 pairs of chromosome in the somatic cell. Similarly, the human being has 23 pairs of the chromosome. The maize plant has 10 pairs of the chromosome. Rice plant has 12 pairs of the chromosome. Similarly, the onion plants have 8 pairs of the chromosome. So the number of chromosome is fixed for all the species. As far the size of the chromosome is concerned, the size of chromosome is variable. The size of chromosome is variable, and the size may varies from 0.2 to 30 0.2 to 30 micron. The smallest chromosome, the largest chromosome in size is found in trillium plant, in which the size of the chromosome is 30 micron. In case of fungi, the size of chromosome is 0.2, and in Drosophila the size of chromosome is 3.5 micron, and the size of chromosome in case of maize is varies from 8 to 10 micron. So in this way, the size of chromosome is also variable. As far the shape of the chromosome is concerned, the shape of the chromosome depends upon the position of the centromere. If the centromere is present, in the median position, the chromosome is called metacentric. If the centromere is present in the submedian position, the chromosome is called submetacentric. If the centromere is present near the end of the tip of the chromosome, or near the end of the chromosome, and one arm is much smaller than the another arm, such chromosome is called acrocentric. And if the centromere is present at the tip of the chromosome, the chromosome is telocentric. In case of telocentric, there is presence of single arm. In case of metacentric chromosome, submetacentric and acrocentric chromosome, there are two arms. In case of metacentric chromosome, both the arms are equal in size, whereas the two arms of the submetacentric and acrocentric chromosomes are not equal. Rather, they are different in size. So in this way, the shape of the chromosome depends upon the position of the centromere in the chromosome. Let us see the structure of chromosome. As you know that the chromosome appears a rod-shaped structure. Here, see the structure. This is the structure. Look at the whiteboard here. This is the structure of a chromosome here. You see there is presence of two arms, and these two arms remain attached at the point of the centromere, which is also known as primary constriction. Primary constriction is also known as centromere. In addition to the primary constriction, in some chromosome there is presence of an additional constriction, which is known as the secondary constriction, and the part of the chromosome present beyond the secondary constriction is known as satellite, knob, or trabant, and this region has nucleolus organizing region. The secondary constriction has nucleolus organizing region, that is also known as NOR, and because the nucleolus is organized at this point, and this is the structure of the chromosome you see here. And now let us see at this structure. This structure shows the two halves of a particular chromosome. That is the chromosome having two sister chromatids. The longitudinal half of a chromosome, the two longitudinal halves of a chromosome constitute the sister chromatid. The sister chromatids are the two longitudinal half of the same chromosome remaining attached at the point of centromere. And when this centromere breaks longitudinally, these two sister chromatids fall to the outer. At this structure, this is the chromosome showing the kinetochore. You know that kinetochore is a three-layered protein disc which remains attached at the point of primary constriction. And this kinetochore is very important because the spindle fibers get attached at this kinetochore during the cell division. So in this way, there is difference between the centromere and kinetochore. Centromere is the primary constriction, and the kinetochore is the three-layered protein disc attached at the centromere. What is the difference? Let us see the difference between the primary and secondary constriction. The chromosome can only bend at the point of primary constriction. That is, the chromosome can show the angular bending only at the point of primary constriction, not at the secondary constriction. And there is presence of a single primary constriction, and there may be more than one secondary constriction in a chromosome. But this secondary secondary constriction cannot show angular bending. So this is the structure of the chromosome and the shape of the chromosome, and just you have seen the size of the chromosome. Kya kasa? Am I clear to all of you? To you? Hello? Kya kasa?
Yes, sir. Yes, sir. Yes, sir.
The whiteboard, are you looking at this? Is this are the diagrams sketched on this whiteboard are visible to you?
Yes, sir. Yes, sir. Yes, sir. It is visible.
ये दिखा तुमको क्रोमोसोम? ये भी?
Yes,
ये
sir.
क्या दिख रहा है? पढ़ो इसको, क्या दिख रहा है? क्या दिख रहा है? NOR, satellite,
yes.
nucleolus, arms, primary constriction, DNA, arms and telomere. Here, see here the two sister chromatids attached at the point of centromere. And look at the size of this chromosome. The size of the chromosome 0.2 into the fungi, 3.5 into Drosophila, 6.0 mu in human, 8 to 10 micron in maize, and 30 micron in trillium. And this is the very important structure. Look here. This is the chromosome having the primary constriction and the three-layered protein disc, which is known as the kinetochore. This kinetochore is very important because the spindle fiber during the cell division remain attached this kinetochore. So this is structure of the this diagram shows this structure of chromosome shows the presence of kinetochore here, which remains attached at the primary constriction. This diagram shows the presence of both the primary constriction and secondary constriction in the chromosome. And the part of, look at this structure, satellite. The part of the chromosome present beyond this secondary constriction is known as satellite, and this is also known as this satellite is also known as इसको नॉब भी कहते हैं, नॉब, और इसी को हम लोग ट्राबेंट भी कहते हैं, ट्राबेंट. It is also known as trabant. So there are three names of the same structure: satellite, knob, or trabant. This is such chromosome having the satellite is known as the SAT chromosome. In this case, there is presence of primary constriction, nucleolar organizer region, and the difference between the primary constriction and secondary constriction is that chromosome can bend only at this primary constriction, not at this secondary constriction. And this is the structure, the longitudinal two halves of the chromosomes, one part and the another half. Two half of the chromosome. So the two halves of the same chromosome constitute sister chromatids, and they remain attached at the point of centromere. So this is the chromosome having the two sister chromatids. This is the chromosome showing the primary and secondary constriction, satellite. This is the chromosome showing the kinetochore, the size of the chromosome. And now let us see that the shape of the chromosome depends upon the position of the centromere, location of the centromere. If the centromere present in the median position, the chromosomes are known as the metacentric chromosome, and the two arms of the metacentric chromosomes are equal. When the position of the centromere is submedian, one of the two arms will be smaller and another arm will be larger, and such chromosomes are known as the metacentric chromosome. And if the centromere is present near the end of the chromosome, one arm will be much smaller than the another arm, and such chromosome is called acrocentric. And if the centromere is present at the tip of the chromosome, the chromosome is called telocentric. In case of telocentric chromosome, there is presence of only one arm, whereas in case of metacentric, submetacentric, and acrocentric, there are presence of two arms. And in case of metacentric, both the arms are equal and they appear V-shaped or inverted V-shaped during the anaphase stage. In case of acrocentric, in case of submetacentric chromosome, it appears like J-shaped or L-shaped, and the telocentric chromosome appear a small I-shaped structure during the cell division. So this is all about the shape. This is all about the size. You have seen here size, shape, and structure of chromosome. So today we have studied the shape, size, and size and structure of chromosome. I will
Chromosome.
upload